All right, everybody. Today we're going to be traveling into the world of 3D figures. And of course, this is three-dimensional. That's what that stands for. And what we're basically going to be doing is breaking down the formulas. But before we get started, of course, like all the notes, they are guided notes. And if you can, print them. The way that I usually present them in class is the front and the back on half sheets of paper. And what I do to do that takes a little bit of manipulation to the file. So if you are printing, you can print 2 sheets of paper on one when you are selecting the option. If you do not want to do that and you're just going to write it down, this is all that needs to be written down. Or if you much prefer to have a larger space of writing, which we usually don't to save trees and everything else, you can of course just print 1 page per page and then go from there. So basically what we're going to be doing is breaking down the formulas and understanding what each, of course, variable in the formula will be describing. And then to know the difference between the surface area, which is outside of something, and then the volume, which is how much that can hold. So I have one real world example. Is this box here. This is a close-up on the box, and as you can see, now turn it all the way around. It of course has an outside, so if I wanted to wrap this on the outside, I would be talking about the surface area. If I to know how much this product box could hold on the inside, I would be talking about the volume. So that is the difference between the two formulas, and why of course we need to know both. And sometimes we'll be talking about the outside, and sometimes we'll be talking about how much we can feel. We'll talk about the units as well at the very end of this. So I'm going to teach this just as if we were in class and preparing for the end of the year. So if we were preparing, the note at the top is exactly right. This is all that we would be able to see on our reference sheet when we are getting to the very end. And so in this case, we still need to know which one of these formulas matches up with which one of the shapes. So we're going to go through that today. And then the surface area, all of that is not given. So if they ever ask for the surface area, you have to be forward thinking about what you are dealing with to be able to get the surface area. So here's where packing away a couple of more formulas into your brain would help you be a bit more successful on the end of the year state test. But now that's neither here nor there. So let's dive right in to see what we have. And the first shape that we're going to talk about, 3D figure, is of course a sphere. And a sphere would be very much so your basketball, a round shape like a baseball or something of that nature. And this one is one of my favorite ones because the only thing you really need to have to be successful in these formulas is the radius. And from prior studies, and when I mean prior, really, before you ever got to the geometry class, you know that the radius would go from the center of a circle, or in this case, the center of the sphere, out to the side. And we know that that would be our radius. Now, I am marking, and I'm also going to draw this little thing right here. And yes, it is very much bootleg. But that kind of lets me know that I am dealing with the 3D shape. That's like the back of the sphere. This is like the front. Okay, anyway. So there's our R to represent our radius. Once we have our radius, we just need to drop it into our formula, and then that is it. Now, remember your order of operations. When you drop this in, we usually deal with parentheses first and then exponents. Here is an exponent. It would do you good to go ahead and do that. So if we had the radius as 6, we know that that would be 6 times 6, or 6 squared first would be 36, and then we go ahead and finish out the operation, which would be multiplication, because they're right next to each other. Now remember, in class we talked about leaving things in terms of pi. You can do so, or you can put the pi in depending on what they ask you to do in the question. So we'll work on that a little bit more in some of the example problems on the other side. Now the volume formula for this is going to be V, and it's going to be 4 over 3 pi r, and then this is going to be cubed r to the third, if you'd rather say that. So one of the formulas that they give you on the reference sheet, of course, is going to be for the sphere. And again, remember, they're not going to say what this is. This is all you're going to see, so you'll have to remember that that goes with our sphere. Okay? And that is it. We're going to keep going. All right. Please do not turn that fraction into a decimal. It will give you a running decimal. Work with the fraction as is. And we'll talk about that, of course, a little bit more as well. So we're going to jump down to the next one, which is going to be a cylinder. And this, of course, would be like a soda can. That we would see. And if we needed to know the outside of the soda can, what we are going to have, of course, is going to be the height and the radius of the base. And when we say base, we know in this case the top and the bottom would count as a base. This is a base, and this at the bottom is also a base. So we know that we have, in this case, a base and a base. Okay, the same thing, the base of this shape and this shape, of course, is a circle and a circle. So the radius for this, of course, it would be the same as in a circle. Okay, and of course your height will be here to here. Now, if for whatever reason this was not a right cylinder, and all that means is that it's standing upright in this case. If it was a slanted cylinder, we'd have to get our height from the center. But however you want to know where your height is fine. From the top to the bottom, I started from the bottom. Now we're here. Whatever you want it to be is fine. So we'll go right along the side of this for our height. Once you have these two numbers, again, all you're doing is plugging it into our formula here. But be certain that you remember that you have to do this operation first. Now, you should look at this formula and say to yourself, this, of course, looks familiar. All right, let's talk about what the formula would be for our volume. So it's going to be one of the three that's at the top. And so it is going to be V, which is going to be equal to big B times the height. Now you're saying to yourself, what is this big B? This big B will always be the area formula for whatever the shape is for your base, whatever that is. So what we need to do, hold on y'all, they didn't know I was in session. All right, and I am back. So what we're going to do is continue on with this. So we have the formula, and we were just about to talk about what this big B was. And I believe I told you this big B stands for the area of the base. So of course the area of the base of this one is going to be the area of the circle. So I want you to either right over here to the side or up underneath here, depending on where you have the room. Let's just do it right here. That our big B, is going to be equal to the area, and yes, I do want you to write this down, of a circle. Now, writing that down, we need to remember what the area of the circle is. And, of course, the area of the circle is going to be pi r squared. All right? So, again, I was saying I hope that this looked familiar over here. Here's just for one base. Here is the base that's at the top and the base is at the bottom. That covers that, your surface area. All right. All right, so we're going to keep moving on. Right on down the line, the next one we're going to look at is a cone. So, of course, the very popular ice cream cone is here. So, in this particular formula right here, to find the surface area, remember that's the outside. So if I needed to know how much material I needed to cover or paint this particular shape, I would be looking for the outside. And sometimes I need to also include the bottom. Sometimes it would be removed, but this includes all of it. So we're going to talk about what each thing represents. So we already know what the radius is. The radius would be coming from our circle that's down here at the bottom. So I'm going to identify our radius from the center to the side of the circle as our radius, nothing new. And of course, this talks about something new, which is the slant height. So let me show you where we're going to get the slant height from. So what a slant height is exactly what you think it is. It's the slanted height. So it is going to be what is going to have the gangster lean right here. This slanted height, this is what is going to be L. Okay, I'm just going to make a cursive L there. And then I'm also going to identify our regular height of this. So my regular height will come from the very tippy top point and drop down to the middle. So of course you probably see it already before I can even tell you that this is going to form what we know very well as a right triangle. As a right triangle. Okay. So of course this is just a regular height, but this L stands for the slant height. So please make sure that you know that, and that's why this is already included here. All right. So if they gave you the regular height and they also gave you the radius, you can of course do our favorite formula to be able to find what L is. And of course that's our A squared plus our B squared. And in this case, opposite of the right angle will be your C squared. That will be solving for your slanted height. Okay, so that's just a breakdown of the formula so that when you see it, you know exactly what it is that you are trying to do. Now in this case, if we are looking for how much water can fit on the inside of this, or how much could this actually hold no matter what the liquid is, this time we are going to be using the last of the three formulas that we have not used from our reference sheet. So this is going to be equal to 1/3 BH. And remember that big B stands for the area of the base. And in this one, our big B is going to be the area of the base, and the base shape is going to be a circle. So again, this is going to be the area of a circle. Please make sure that you include this. This is important. And of course, the area of the circle is the same area of the circle that it was above. Please do not neglect that. Okay. Our next one is going to be, of course, our square pyramid. Now, there could be a rectangular pyramid, meaning that the bottoms will not all have the same sides. But it is pretty much the same concept here. Here, again, we're going to be looking for the side length of a base. So the side length of the base, that's what this S is going to stand for here. This is still the same side. So whatever this is will be our side. Okay, and there are 4 equal ones since it is a square. So in this case, I hope you can see that I'm writing small. So in this case, that's the number that we would fill in. Whatever the measurement is, here is what we would fill in here and what we would fill in here. And again, we are dealing with yet again another slanted height. So let me show you the slanted height. Okay, that would be our slanted height. Now again, to find this slanted height, if you were given the regular height dropping down to the center of the square and then out to the side, you would be able to solve for what this is, the slanted height. Okay, and we'll practice that at some point in time. And then we'll talk about how much this object can hold. Again, what we're going to have is going to be the same exact formula as above. It's going to be 1/3 of the base times the height. Okay, so remember this line on the inside, that was our height, just a regular height. So now that we know that, we have to know what this big B stands for. And the big B is going to be the area of the base. So we have to look at the shape that is on the base here. And the shape that is on the base is the square. So that's what we need to have here. Notice it is not a circle, so we're not going to write the area of the circle. We're going to write down that it is the area of a square. Now, of course, in knowing, we have to know what the area of the square is. So, of course, the area of the square is just basically going to be your length times your width. And each time that we say this, what we're doing is replacing this B with the L times the W. Okay? Each time we talk about this B here, we're going to be replacing it with pi r squared. That's what we're dropping in here. Okay? Sometimes they will give you the base of the area, so you don't, the base of the shape. So sometimes they will give you this and it won't be needed to actually solve for it. Sometimes all you'll have is the height and the radius and you'll need to do this. Okay? All right, good. So we will continue on. The next one is the rectangular prism. Now the rectangular prism can be more than just the rectangular prism. It is a rectangular prism because the tops are and the bottom, or the base areas, are going to be rectangles. This could be a square. This could be a triangle, which then it would be a triangular prism. It could be a different type of polygon. So we know that that's 3 or more sides that are closed. So depending on what the polygon is at the top, that's what kind of prism it is going to be. So we need to make sure we have a good understanding of that, but we're just going to deal with the rectangular one right now. And we need to know for the surface area, remember that is all the way outside, this side, in the back, and over here on the left. And then our base, our top and our bottom. So in able for us to solve for that, what we're going to do is multiply times 2 these objects. So we need to have the length, the width, and the height. The length, the width, and the height. So remember, you'll have your length and your width, which would consist of here, and your height would be straight up and down. Okay, so length and width, and then your height. Then when you're filling this in, all you're going to do is do the length times the width, and then add that to the length times the height, and then add that to the width times the height. So remember, in your order of operations, what are you doing first? What is in the parentheses? And inside of the parentheses, the first order is multiplication, multiplication, multiplication. And then only then are you combining, adding the 3 together. And right after you do so, you will then take it and multiply it by 2. So it is important for us to make sure that we remember what our order is going to be. Okay, so we'll choose this as the width. We'll choose this as the length, or vice versa. And then this will be our height. Okay. All right. So what formula will we use for this one? You've probably guessed it. So the volume formula for this one is going to be our big B times the height. And again, remember the big B is the area of the base, whatever the base shape is. And in this one, they tell us that it is going to be rectangular. So we know that our big B is going to be the area of a rectangle. Okay, I barely squeezed that in there. All right, so the area of a rectangle, and we know the area of a rectangle to be the same as the area of the square. We are just looking basically at the length times the width. Now, and before I go on, I'm sorry, I should also say the area of a square, because all of the sides are the same, can also be identified as the side square, because that's exactly what you're going to have. So let's say that the length and the width is 5 and it's 5. So 5 times 5 would be 25. S is the side, which would be 5. 5 squared, of course, would be 25. So it is the same thing, just in case you're thinking, why would she write something different there? So that would be the exact same thing, okay? All right, good. So we're going to go down to the cube, and this is going to be the last of the ones that we're going to do as kind of breaking down the formulas. Now, there are more, because remember when I talked about the prism here, I talked about having different tops and bottoms. And then you could also have different types of pyramids as well, depending on what your shape is. At the bottom, it might not be a square, it might be a rectangle. So we want to make sure, or a different kind of polygon. So we want to make sure that we have a good understanding of how these formulas work, and then we'll work out some and then go from there. Last one, for the surface area of the cube, we know that it's going to have 6 sides. So we know all the way around, we'd have 1, 2, back here in the back would make 3, and over here to our left would then make 4. And then a top would be the 5, and at the bottom would be 6. So the only thing that we have to do to get the surface area, and that is if I needed to cover the outside of the shape, is multiply that 6 times the side, and then of course that squared. So remember, in our order of operations, you're going to take this, and let's use the same number as 5. If this is 5, then it'd be 5 squared. And then after the 5 squared is when we then multiply it by 6. Okay? All right. Pretty simple there. And so, of course, for this formula, we're going to have the same one as above for our volume, which would be the B times H. So remember that big B is going to be the area of the base, and the area of the base in this case is going to be the area of a square. All right, area of the square. And then, of course, the area of the square, again, would be the length times the width, or remember, the length times the width could be certainly described as S squared. Okay, so let me write this, and then I'm going to write or S squared. Okay, and I'm going to go back up here and do the same thing, or S squared, just so that you can remember, just in case you see it. All right, so the big question is, of course, what does the B represent in the volume formulas? And of course, we've been saying it. It is going to always be the area of the base shape. Whatever that shape is going to be, it's going to be the area of that base shape. Please make sure that you remember that, because we are going to be using that. Okay,